Straight lines. Question number 1. A straight line passing through the point 2, 2 meets the lines root 3x plus y equal to 0, root 3x minus y equal to 0 in the points A, B respectively. If triangle OAB is an equilateral triangle, then equation of the line AB is. So here, this point is A, this point is B. Coordinate of this point is 2 comma 2, and this is first line, 3x minus y equal to 0. This is second line, 3x plus y equal to 0. This is origin, and this is x-axis, this is x-axis, this is y-axis. Now, if we find theta of second line and first line, we will see this angle will be 60 degree. This angle will be 120 degree. That is the root 3x minus y equal to 0. This gives y equal to root 3x, where theta 60 degree, and second line root 3y plus x equal to 0 will give y equal to minus 1 upon root 3 x, here theta equal to 120 degree. Now, triangle OAB is equilateral triangle. So this point will also be at same height. That is, this point will be minus 2.2. And by symmetry, we can say that equation of the line AB is y equal to 2. Now, let's consider next question. The locus of centroid of triangle whose vertices are a cos t, a sin t, a sin t, comma, minus b cos t, and 1, 0 is here. A and b are non-zero integers. Now, we are given a triangle. Points are a cos t, a sin t, a sin t, minus b cos t, and this point is 1 comma 0. That centroid has coordinate h comma a. So h will be equal to a cos t plus b sin t plus 1 divided by 3, which will give 3h equal to a cos t plus b sin t plus 1, or 3h minus 1 equals a cos t plus b sin t. So put this equation above. Now we write y coordinates, that is k equals a sin t minus b cos t plus 0 divided by 3, from where we get 3k equals a sin t minus b cos t. Suppose this is equation number 2. Now, squaring and adding these two equations, 3h minus 1 whole square plus 3k whole square will give a cos t plus b sin t whole square plus a sin t minus b cos t whole square. If we simplify RHS, we get just a square plus b square. Here we can apply formula a plus b whole square, and here a minus b whole square. So, and cos square t plus sin square t equal to 1. We will get a square plus b square. Now, to get locus, we replace h by x, and k by y. So, our final equation will be 3x minus 1 whole square plus 3y whole square, that is 9y square, equal to a square plus b square, which is our answer. Now, let's go to next question. Question number 3. Let a 2 comma minus 3 and b minus 2 comma 1 be vertices of triangle ABC. So, we have a triangle 2 comma minus 3, which is a, and b is minus 2 comma 1. If the centroid of the triangle traverses on straight line 2x plus 3y equal to 1, then the locus of vertex C is. Centroid traverses on this line, and we have to find out the locus of vertex C. Suppose vertex C is x1, y1. Now, suppose we take centroid xy. So we evaluate. X will be equal to x1 plus x2 plus x3, that is 2 minus 2 plus x1 divided by 3. So this will give x equal to x1 upon 3. Similarly, y will be equal to minus 3 plus 1 plus y1 divided by 3, which will give y equal to y1 minus 2 divided by 3. Now, we can put these values in this equation 2x plus 3y plus 1. So, putting the values, twice of x1 upon 3 plus 3 times y1 minus 2 upon 3 equal to 1. Now, we simplify, so we get 2x1 plus 3y1 minus 6 equal to 3, or 2x1 plus 3y1 equal to 9. So we can replace x1 and y1 by xy. So we get 2x plus 3y equal to 9, which is locus of vertex C. Now, let's go to next question. Question number 4. The lines parallel to x-axis and passing to the point of intersection of line this and this is. So here it is similar. The line parallel to x-axis and passing through the point of intersection of lines ax plus 2by plus 3b equal to 0 and bx minus 2ay minus 3a equal to 0 is. So, suppose there are two lines L1 and L2. In that case, a line passing through their intersection is given by L1 plus lambda times L2 equal to 0. So we put the values. So ax plus 2by plus 3b plus lambda times bx minus 2ay minus 3a equals 0. Now we further simplify. So we get a plus lambda b times x plus y times 2b minus 2a lambda plus 3b minus 3a equal to 0. Since line is parallel to x-axis, it means its slope is 0. So parallel, so we write slope will be equal to negative of minus a plus lambda b divided by 2b minus 2a lambda must be equal to 0, from where we get lambda equal to minus a upon b. Now, we can put the value of lambda in this equation. So we are putting the value in this equation. So it will give 0 times x plus y times 2b plus a upon b into 2a plus 3b minus 3a times minus a upon b equal to 0, from where if we simplify we get y equal to minus 3 by 2. So this is required equation. Now let's consider next question. The perpendicular bisector of the line segment joining P1, 4 and Q, K, 3 has y-intercept minus 4. What is possible value of P? Here, P is 1, 4, Q is K, 3, and this is perpendicular bisector. So, and it meets y-axis on point 0, minus 4 because y-intercept is minus 4. Now we have to find out what is possible value of K. So, we find the slope of line. Suppose this is line L1 and this is line L2. So we find their slopes and their product will be minus 1. So suppose slope of this line L1 we find, so that is M1 equal to y2 minus y1, that is 4 minus 3 divided by 1 minus k, that is 1 upon 1 minus k. And second line slope of this will be midpoint perpendicular bisector. So you can write the coordinate 1 plus k divided by 2 and 7 by 2, and this point is 0 comma minus 4. So we find m2, and m2 will be 7 by 2 plus 4 divided by k plus 1 divided by 2. That will give 15 divided by k plus 1. Now, since m1 into m2 is minus 1 because these two lines are perpendicular, so we put the values 1 upon 1 minus k times 15 upon k plus 1 equal to minus 1, which will give 15 equals k square minus 1, or k square equal to 16, from where we get k equal to plus minus 4, which is our answer. Thank you for watching.